I want to stay with this theme of matrix multiplication and show you another cool application for matrices and multiplying them, raising them into powers and so forth, which is, it would be a horrible thing to do by hand, but we are armed with technology nowadays, boys and girls, right? We've got these crazy things. And using these things, we can solve some very complicated problems. And the application I'd like to show you now is how to track populations through age groups. Let's say that you're raising cattle and your herd of cattle, you've paid attention to the age distributions through the years, and you know the following facts about your group of cattle. You know their birth rates going from one age group to another. In other words, cattle of this age do not actually have any cows of their own, but then when they get up about, they'll grow at a rate of 50%. So however many are in this group, 2 years later, and I'm doing things on a 2-year cycle, half of that number will reappear in this group as being born into that group, and so forth. And so you see, as they get older, they're reproducing more, and then as they get very old, their reproductive cycle kind of drops off. Also, we have studied the survival rates. As younglings, there's a slightly higher chance that they won't survive. That means a lower rate that they do survive. That's the 0.7. And then about 0.9, there's almost 100% chance they'll survive to the next thing. There's always sickness, illnesses, and these kind of things. But then as they get older, they start to die from old age. So the survival rate goes down. And then I'm assuming here that nothing would live past 12 years. There's a 0% probability that they would live past 12 years. So here's my question. If I start with 40 head, and they're all the same age, I go to the stockyards and I buy 40 head of cattle, they're all 2 years old. What would be the age distribution of my herd in 30 years? Okay, this could be important. Maybe I want to take a certain segment of those, just like I had at the stockyards, and sell them off. Maybe there's different things you can do with your animal at different age groups. So we're just going to try to track them, but we're going to track them by groups, and we're going to do these things on 2-year cycles. Okay? Well, let's think about how you do this year to year, and I should say every 2 year to 2 year in my example. If I have a general kind of age distribution, so many in one group, so many in the other, and so forth, and I think about how do you get in that first age group? Those are the young ones, so they have to be born into that age group. So to get the total in the next group, in the next cycle that are in that youngest age group, I look at the birth rates for each of these groups, and I multiply by the number that are in there. So 0 for the first one, 0.5 if you remember these numbers in the birth rates for the second, 1.1 for the third, and so on. Okay? And that's a fairly messy calculation, but I can clean it up a little bit using matrices. Watch this. I could say, well, just take your birth rates and put those in a row of a matrix. Take my age distribution, put that in the column, and then all of a sudden that's matrix multiplication that I'm doing. Okay? If I worry about, okay, how many survive to get into that second age group, well, that's the way you get there. You're not born into that second age group. You live to make it into that second age group. And I know the survival rates. I know that 70% of those in the first age group will then end up in the second age group, okay, after a 2-year cycle. And again, I can phrase that. Now, this looks messier than this, but I have a method to my madness. I'm going to take this survival rate, fill in the rest with zeros, and I'll just do a little, again, matrix multiplication here. And that gives me that result. Okay. And then the third age group would be a similar thing. 0.9% of those survive from the second age group into the third age group, which I could phrase as matrix multiplication. Okay? So the way I would do this in general is I'll construct a 6x6 matrix. If you have more age groups, you'd have a bigger matrix. I have 6 age groups. And I'll put those birth rates across the top. And then when I multiply by my age distribution, that will give me the number in that first age group in the next cycle. And then 0.7 is the, now these are birth rates. To get the others I use, I'm sorry, excuse me, These are survival rates. So I take 7% of the first group, fill in with zeros as I did just a few minutes ago. To get the second one, I put zeros here. You'll notice that these are falling right below the main diagonal, okay? And so I can just fill in the rest of my matrix like that. We call this a Leslie matrix after the mathematician who kind of developed this idea. You put the birth rates along the top, and then along that main diagonal you still have zeros. You have zeros everywhere else, except for that diagonal right below the main diagonal, you put in then the survival rates. Okay? And then I'll show you how you can use that then to plot the number of animals in each age group. If I do this after 1 2-year cycle, okay, what I do is I'll multiply this by my original distribution, which is right here. I have 40 in this second age group. And all that's going to do, it's going to just kind of peel this part off and multiply by 40, right? 0 times this, all those, and all these will be times 0. But 0.5 times 40 will give me 20. 0.9 right here times 40 will give me 36. So that's how many I would have in the age groups after the first iteration, after that first 2-year cycle. Then, if I want to do it for after 4 years, that would be the second 2-year cycle. So again, I would multiply by this Leslie matrix. Let me show you this. Times my original result. Do the arithmetic. This is just a little matrix multiplication. I'm not showing you the 0 entries or the 0 products. And then starting to get fractional part of cows, which is not always a good thing, but you realize we're going to have to do a little bit of rounding here when we're done. The quick way to do this is not to do the multiplication 15 times, but to simply raise that Leslie matrix. If you notice here, to get the answer, D1, I got that by multiplying by L times the original, so I could raise L to the second power. And just like before when I was dealing with the probabilities in the transition matrices, that's the quick way to do it. So to get the age distribution after 30 years, okay, that's 15 2-year cycles, I would just raise that matrix to the 15th power. And again, that's something we do on the graphing calculator. You can use a computer algebra system to do that. And it's fairly messy, but what do I care? The calculator's doing it, not me. Multiply that out, and it gives me the age distribution for each of those age groups. Okay, and as you can see here, things have grown very, very fast. And in fact, I've got over, it looks like I've got nearly 1,000 cows now. That could be an issue. I may not have enough grass and hay and corn and things to feed these many cows. So we also have, what you'd have to do in that situation is go back and say, well, you know, probably I'm going to start selling some off. And you would reflect that sell-off in your survival rates. It's not necessarily survival, are they alive? It's survival, do they make it to the next group? And at some point there, you may start selling them off, and that would lower then what the so-called survival rate. Okay, again, I have a couple slides to show you a summary of what we've talked about, and we'll get ready for the next segment.